Assalamu alaikum students. A very good morning to you all. So in the previous class, we have discussed the topics containing ionic bond, covalent bond and coordinate covalent bond. But first of all, in the starting of the chapter, we deal with the question that why an atom tends to form a covalent bond. Why? And we got the answer, and then afterwards we have discussed about the chemical bond and its types, and in conclusion we have known now that we have three types of bonds: covalent bond, ionic bond, and coordinate covalent bond, that is also known as dative covalent bond. So now moving towards our next topic, that what are some forces that holds the molecules or bounds the molecules each together. So the today's topic is intermolecular forces, dipole-dipole interaction, hydrogen bonding, and the properties of the characteristics of the polar and non-polar compounds. So starting with our lecture, first of all, we are going to deal with the intermolecular forces. What basically the intermolecular forces are, you can see here clearly that intermolecular forces are defined as the set of all the forces that occurs between two neighboring molecules. Inter means, yes students, inter means between, like that you are right now in a school and afterward you will go into the college and then you will go inshallah into the university. So in between the school and university, you did intermediate exams. You will get to pass intermediate exams, and inter is the word that is used to represent the thing that is in between of something. So intermolecular refers to, inter means between and molecular means molecule. So the force that holds the two molecule or that is present in between the two molecules is called as intermolecular forces. यानी कि इंटर का मतलब हमारे पास है दरमियान, सेंटर में, और मॉलिक्यूल का मतलब कि भाई दो मॉलिक्यूल्स के दरमियान। इंटर मॉलिक्यूल का मतलब क्या है कि दो मॉलिक्यूल्स के दरमियान जो फोर्स होगी ना वो हमारे पास क्या कहलाएगी, इंटर मॉलिक्यूलर फोर्सेस। ओके, and this force holds the two molecules together. Here you can see the example of intermolecular forces. There is a one molecule of HCl and there is another molecule of HCl. These two HCl molecules are bonded together or attracted together by the force that is known as intermolecular force. Now here another term, intramolecular. Intermolecules means between the two molecules. Intramolecules means within the molecule. It means that this is the one molecule. It contains hydrogen and chlorine atom. And the bond between them, the force that attracted the hydrogen and chlorine each other, is known as intramolecular. And what is intermolecular? The molecular force in between the two different molecules or two same molecules is called as intermolecular force. Okay, यानी कि intermolecular force क्या होती है, दो molecules के दरम्यान कोई attraction होगी तो वो intermolecule, और एक molecule के अंदर जो elements है उनके दरम्यान जो attraction होगी वो होगी intramolecular force. Got my point class? Now moving towards our next slide, there is another type of molecular force, intermolecular force, that is dipole-dipole interaction. In this, you can clearly see that dipole-dipole interaction results when two dipolar molecules interact with each other. Now, first of all, we have to know about what is dipolar molecule, why we are saying it dipolar. So, consider the two poles, electricity, two electricity poles, one is here and one is here. This pole has positive charge and this pole has negative charge. So you know that the positive and negative charge attract each other by the electrostatic force. And this attraction is due to the dipolar attraction. You know that we have two, di means two and pole means pole. We have two different poles and these two different poles attract each other and covalently bonded each other or ionically bonded and forms a new compound. So remember students, always the dipole-dipole interaction results when the two dipolar molecules interact with each other. Okay, when partially negative portion of one of the polar molecule is attracted to the partially positive portion of the second polar molecule, the electrostatic attraction is created between two molecules, and these forces are called dipole-dipole interaction. Here you can see that there is one molecule, and here is second molecule, and here is a third molecule. So you can clearly see here that this is negatively charged and this is positively charged. This is negative, this is positive. Always the negative and positive, or positive and negative, in short, the two different or opposite charges forms a force in between them to attract each other, and this force is known as electrostatic force. And the bonding or the interaction that occurs due to the due to the electrostatic force between the two different poles of a molecule, this force is known as dipole-dipole interaction. Now moving towards our next slide, you can here clearly see that this is one molecule and this is another molecule. This is ICL, this is ICF. Dipole-dipole interaction is an intermolecular force that is caused by dipoles. Here you can see that we have dipoles. There is negative charge on it, and here it is positive charge. So what will be happen? These hearts are representing the attraction force. Okay, these hearts are representing the attraction force in between these two molecules. You know that the two opposite charge molecules attracted each other by means of electrostatic force, and this interaction or attraction is known as dipole-dipole interaction. Okay, and in there you can see clearly that this is negative charge and this is also negative charge, and we know that always the two same charges opposes or repel each other. So in this sense you can see that these two faces are too much sad, and there the reason of their sadness that they have the similar charges. They cannot attract by each other. They cannot form the dipole-dipole force. Got my point? I hope so. Through this picture or through this representation, you have your views clear about the dipole-dipole interaction. Moving towards our next slide. Yes, the another point, the dipole-dipole interaction can be seen in hydrogen chloride. Here's an example. You can know that chlorine atoms are much more electronegative than hydrogen. Yes, we know that the group 7A elements, especially fluorine, chlorine, have a highest electronegativity among all the elements, and these are highly electronegative elements. And we know that hydrogen is positive element. So here the partial negative charge is created on chlorine, and in turn a partial positive charge on hydrogen due to electronegativity difference. Now here you can see that in this ICL molecule, hydrogen is partial positive and chlorine is partial negative. The sigma sign, this sign is representing the partial. Partial means आधा, यानी कि ये पूरा मॉलिक्यूल है ICL जिसमें आधा हमारे पास पॉजिटिव से बना हुआ है और आधा आधा नेगेटिव से, और ये पॉजिटिव नेगेटिव दो चार्जेस थे तभी ये अट्रैक्ट हुए और तभी ICL का मॉलिक्यूल बना. तो हाइड्रोजन हमारे पास क्या है, पार्शियल पॉजिटिव है, और क्लोरीन हमारे पास क्या है, पार्शियल नेगेटिव है. So these two molecules come closer to each other by the means of attractive forces, and this force between the two different poles is known as dipole-dipole interaction. Got my point? Now, another type of bonding or interaction we are going to deal with. This is hydrogen bonding. Okay. By name, you can easily guess that this bonding is due to the hydrogen element. So what basically the hydrogen bond is? So hydrogen bonding is a type of dipole-dipole interaction. Basically, it is a kind of dipole-dipole interaction, but it forms with the help of hydrogen element. So when hydrogen forms polar covalent bond with more electronegative element like nitrogen, oxygen, fluorine, chlorine, sulfur. So the type of bond that forms in between these electronegative elements and the hydrogen atom is called as hydrogen bonding. ओके, यानी कि जब भी हमारे पास हाइड्रोजन किसी ऐसे एलिमेंट के साथ जो कि हाईली इलेक्ट्रोनेगेटिव हो, उसके साथ बॉन्ड बनाएगा, तो वो जो बॉन्डिंग कहलाएगी उसे हम हाइड्रोजन बॉन्डिंग कहेंगे। क्यों कहेंगे? क्योंकि वो बॉन्ड हाइड्रोजन ने बनाया है। और कैसे बनाया है? उसने बनाया है अपने आप को किसी हाईली इलेक्ट्रोनेगेटिव एलिमेंट के साथ बाउंड करने के बाद। So the interaction between partially positive charge and hydrogen atom of one molecule with electronegative atom holds the molecule, and this type of bonding is called as hydrogen bonding. See an example. You can clearly see here that we have a water molecule. The best example of hydrogen bonding is water. In water, you know that there are number of water molecules bonded together with hydrogen bonding. Oxygen is electronegative element and hydrogen is electropositive. So in water, the hydrogen forms a bond with oxygen molecule of another water molecule and makes a long chain that holds the water in a particular manner. So this bonding between the hydrogen and the highly electronegative element is called as hydrogen bonding. This blue lines, blue dotted lines is representing the hydrogen bonding. And class, remember that always the hydrogen bondings are represented by dotted lines. Always the hydrogen bondings are represented by dotted lines. Remember that this is the correct representation of representing the hydrogen bond. Now we have another topic class, that is polar and non-polar compound. You know that what is polar? Polar compound are those compounds that have the two poles, positive and negative. But non-polar compounds doesn't have the two opposite poles, they have the similar poles. So the non-polar compounds, covalent compounds are generally insoluble in water, while polar compounds are soluble in water. In class, I have foretold you that water is a polar solvent because water have a H plus and O minus. 2H plus when bounds with the oxygen molecule, so it forms a one water molecule. So it means that the water is a polar solvent. And according to like dissolved like theory, always the polar compounds can be easily soluble in polar solvents, while the non-polar compounds are only soluble in non-polar solvents. So water is a polar solvent. So non-polar compounds cannot be dissolved in a water. They are insoluble, but the polar covalent compounds are soluble in water. The second point is non-polar covalent compounds do not conduct electricity in the solid, molten or aqueous solution. Like that, in ionic bonding topic, we have discussed the sodium chloride, that sodium chloride is a polar compound. It forms by the two poles. So in the sodium chloride, I have foretold you that when the molten state or an aqueous solution of sodium chloride comes in contact with the wires containing electric current, so it can conduct electricity. They can conduct electricity because they are polar compounds. But the non-polar compounds doesn't have the free electrons, doesn't have the two opposite poles, so they are not eligible to conduct any sort of electricity. Okay. The third point is non-polar covalent compounds are soluble in non-polar solvents like petrol, benzene. Yes, the non-polar cannot be soluble in water, but can be soluble in non-polar solvent like petrol, benzene. And while polar compounds are insoluble in non-polar solvents because they are only soluble in water, polar compounds. Few examples of polar covalent compounds are H2SO4, sulfuric acid, water, hydrochloric acid, hydrogen fluoride, hydrogen bromide, hydrogen iodide. These are the examples of some polar covalent compounds. And the examples of non-polar covalent compounds are carbon dioxide, CH4 methane, sorry, there is a 4, CH4 methane, and C2H2. We have ethene. Okay, so these are the some examples of polar compounds and non-polar compounds, and we have discussed about their properties. They differ in their properties. So class, in this lecture we have covered the intermolecular force, intramolecular force, dipole-dipole interaction, how it happens, what is hydrogen bonding, why it is called as hydrogen bonding, and how it is happening, and what are the basic difference upon properties in between polar and non-polar compound. So this is the all that we discuss in today's lecture, and I hope so that you will understood all the topics very clearly, and now you have a solid crystal clear views about these topics. But if you have still any kind of query, any kind of confusion, and any sort of question regarding these topics, so you can ask me in your next class. Inshallah, I will clear your all the misunderstandings and all the confusions in your next class. Thank you so much, class, for your precious time, for cooperating with me, and thank you for your time, and goodbye. See you in the classroom. Thank you so much.